Get a messy expression? Anyone? We give it a name, right? And what name could we give to this expression here? Right? Edwin will leave us. What does this expression represent? Integral over all the people inside of their marginal utility times that. What name could we give it that's a bit like that up there? Yeah. What is that? What would that represent?
Like excluding.
Well, so this is the average marginal utility again, but it's for the average consumer who's participating in the market, rather than just for the average marginal consumer, right? This was for the consumers who were marginal or indifferent between purchasing the product or not. This is for the average consumer, right? And so we can write u bar prime as this integral over n. That's the average value to an average consumer of having a bit more quality. Okay, so then we can get a very simple formula for the optimum. Why? Because we need to set this equal to that, and that just gives us n times the average marginal utility to an average consumer is equal to the marginal cost of quality. And that's super intuitive, right? It says, how high quality should we set? Well, we should set it at exactly the point where the value that it brings to people, on average, times the number of people, is equal to the cost of providing that to them. Right? Okay. On the other hand, what's the derivative of profits with respect to the quality? Well, notice we're holding fixed the number of people, so we can ignore this n here. We can ignore that there. We take the derivative of this, and we get the marginal cost of quality. And then, how much does the price change? Well, what we said is that when the quality increases, the price increases by the average marginal utility of a marginal person. Right? So we get this u prime tilde. And so we get a different expression, which is the number of people times the average marginal utility of a marginal person is equal to the marginal cost of quality. So the socially optimum would be to set the average marginal utility of an average consumer equal to the cost of quality, whereas the monopolist sets the average marginal utility of a marginal consumer equal to the marginal cost of quality. So, in other words, the monopolist is going to cater to the marginal consumers, not to the average consumers. And that's inefficient. That is called the Spence distortion. And that's what I was talking about earlier. You don't pay attention to the consumers who are definitely going to buy your product. You pay attention to the ones who are marginal. Right? So quality will be too high or too low, depending on whether the marginal or average inframarginal consumers value it more. If the inframarginal consumers value it more, there will be too high quality. If the marginal consumers value it more, there will be too high quality. If they value it less, there will be too low quality. And in some cases, this can be offset by the inframarginal consumers posting a bunch of nasty comments on the website, or denouncing the company or complaining or stuff like that. But for the most part, the company's going to care more about its profits than about complaints, right? Okay, one very simple example of this was given by Harold Hotelling. And he imagined that there was a product characteristic which was just on a line between 0 and 1, and that consumers lived on the line somewhere between 0 and 1, and they were uniformly distributed. So a consumer has to pay a cost in order to visit the firm. Some cost of transportation times the distance between the consumer, this should be an absolute value, the distance between the consumer and the firm. Right? So this is sort of like the classic example of horizontal preferences. Everyone wants the firm to be located right next to them, right? Rather than far away from them. And all consumers are going to buy either from one firm or from another firm. So there's two companies. So this is technically not a monopoly, but the logic is going to be very similar to the Spence case. So suppose that the two companies started at positions row 1 and row 2. Jalin, where would they want to move if they started at row 1 and row 2? Just by Spence's logic. So the consumers have to buy from one of the two firms. There are two different positions. Where are the firms going to want to move? Towards which consumer?
The one that's closer to, so the marginal.
So the marginal consumer, and who's just marginal between the two firms? So consumers are going to buy from whoever is closest to them, right? So what consumer is going to be just marginal between the two firms? So which consumer is going to be indifferent between buying from this firm and buying from that firm? Imagine that we have a beach, right? And there's a firm here and there's a firm here, right? And you're a consumer. You want to buy from whichever one's closest to you. Which firm will you buy from? The closer one, right? So which consumer is going to be just indifferent between buying from the two firms? The one right in the middle, right? So the firms are always going to want to move towards whichever consumer is in the middle between them, right? Because that's the marginal consumer, right? And that means you always move to the point that's halfway between you and your competitor, right? And that means you always move towards your competitor, right? And this holds at every point. So no matter how close you are to your competitor, you always want to move towards him, right? Because the marginal consumer is always in between you. And so that means that everyone is going to end up at the same spot, right? And this spot has to be in the center. Why? Well, if it's not in the center, then imagine you were at you were at this point on the beach, like right here, and both of them were there. Well, then one of the carts could move just slightly to this side, and it could get everyone on that side, right? And leave the other guy with only the ones on that side. So it's got to be that they're at the same point and in the center. So this leads to a very stark prediction. Joshua? Yeah. What's the prediction of the model?
Isn't it just that all the firms should be in the same spot?
And what spot will they be in?
Right in the middle.
Yeah, so the Hotelling's law says that all firms will be in the center of the, will end up in the center of the beach. In particular, let's show this mathematically. What is the value to a consumer of distance? Imagine that I change my position, right? My row. Xiaolan? Xiaolan? No? Okay. So the value to a consumer of changing row, right? Imagine that they have the same prices and they're positioned on two sides. One is above 1/2, one is below 1/2. They're sort of evenly, and so the point between them is 1/2, right? The willingness to pay for an increase in row J is negative T for any consumer who is to the left of me, and the marginal consumer is always to the left of me, right? So their willingness to pay is always negative T, right? And there's no cost to me of moving, so I'm always going to move. I'm going to, my first order condition is negative T is equal to 0, so I'm always going to move towards the center, right? And so they must be on top of one another at equilibrium. If this point is not 1/2, Kenneth, remind us what happens if this point is not 1/2.
then the other consumer would try to move to the other side and gain the.
Yeah, so if it was at 1/3, which side would you move towards? Imagine we were on top of each other at, 1/3, which side would you move to?
Which is the one that you can gain more consumers.
Yeah, so there's if you're at 1/3 out of 1, you're going to move just higher, right? Because you can get the top 2/3 of the. Oh, that's right. Okay, so suppose it was like 1/4. If you move to 1/4 plus a tiny, tiny bit, I get everyone to the right. I get those 3/4 of consumers who are to the right. So it's clearly better than staying at 1/4. So the only stable thing is that both people are at 1/2. This is called Hotelling's law. So this simple model, both firms end up at the center, right? This is a very famous result. And notice that it's really inefficient. Yeah, go ahead.
Yeah, my question is, could things possibly be different as you introduce more firms? Because,
Yeah.
for instance, if you had like 5 firms, if they're all in the center, then
Yeah.
one firm would have incentive to move slightly to the right, because you would capture everyone to the right while losing only a little bit, because all the other 4 firms are competing for people on the left,
Yeah.
and halfway between.
No,
So,
that's true. That's true. So things do change as you get more firms. We're going to focus on the 2-firm case for now.
but it could lead to a different kind of stability equilibrium, where
Yeah, different things get really weird. So in fact, there's no equilibrium when there's 3 firms. So things can get pretty weird. Yeah.
How do you know that when the firms move towards the center, they don't lose the consumers that are?
Because we assume that all consumers definitely buy from one firm. That's going to be crucial. We'll talk about it. Okay. So everyone is better off if the firms were to spread out and be at 0.25 and 0.75, because then people would have things much close. On average, would have things much closer to them, right? But no firm wants to do this on its own. A monopolist would be better. It would move out to 0.25 and 0.75. So this is very widely applied, and it's pretty relevant in terms of geography, because people do want things that are like physically close to them. And in fact, you see a lot of clustering like this. So I don't know if people have noticed, there tend to be like Chinatowns. There tend to be like areas where all the good restaurants of some particular type are like clustered into a very small area. And that's sort of really inefficient, because people would all like to have nice restaurants, Chinese restaurants near them. But instead they all have to go to Chinatown to go to the Chinese restaurants, because that's where like the center of the market for Chinese food is. So everybody like tries to get a piece of that action, right? The problem is, who was it that just said that? Was it you, David? No. Oh yeah, Mike did. So the point is that some consumers might buy nothing rather than buying from one of the 2 firms, and these people are marginal consumers too, and so you want to keep them as well, right? And also, not everything is horizontal like this. So, more generally, you're going to have some consumers who you might lose because they'll buy nothing. You might have some consumers who you might lose because they'll buy from your competitor, right? And you have to cater to both of those groups at the same time. And so the key question in terms of like what would be more efficient, here competition was inefficient because it drove everyone to the center, where it would be better to spread them out. But in general, the question is going to be, are the consumers who are switching between you and your competitor more similar to the average consumer than the consumers who are thinking about buying what you're selling or nothing, right? If the ones who are switching are more representative, competition is going to be good. It's going to make you cater more to the average consumer. If the people who are exiting are more representative, then competition is going to be bad, right? And a key determinant of that is whether the thing that you're choosing is the key thing that separates you from your competitor. So in the Hotelling model, right, the only thing you chose was where on the beach you were located. So the people who are just in between you, like the only thing about them is that they are like, in between you, and so you're always going to try to cater to that marginal guy. However, imagine that you were just stuck at whatever point on the beach you were, and now you're choosing how much sugar